Okay, up to this point, we've been doing hypothesis testing for the population average, mu, or the mean, mu. But now we're going to shift gears a little bit, and we're now going to do hypothesis testing for the proportion pi. Okay, so we're going to do pretty much the exact same thing we've been doing. It's just we're changing a couple steps. I shouldn't even say steps, just mostly formulas and notation. So we're still going to stick with our 5-step process, and the step 1 is still formulating our hypotheses. So now I've written the exact same thing, except everywhere where I used to have mu, I now have pi. So we're now interested in whether the true proportion is equal to some value, or less than, or greater than some value. Step 2, we now want to calculate our test statistic. So as before, we're going to take our data, our sample, and we're going to get our point estimate p. Recall our estimate is just the number of successes over trials, so x over n. And then we're going to calculate our test statistic. But before we were using t-stat, we're now going to use z-stat. And our formula for z-stat is right here. So it's p minus the hypothesized value divided by the square root of the hypothesized value times 1 minus pi naught divided by n. And so just how t-stat represented the number of standard deviations, we're now saying z-stat represents the number of standard deviations that p is above or below pi naught. So you can see all of these things are following the exact same process as before. We're just using proportion instead of means, and our notation is changing a little bit. So we do have to state one assumption for this z-stat to be valid, and that's just that our number of successes, x, is at least 5, and the number of failures, n minus x, is at least 5 as well, because then we can assume normality. This will provide normality. Okay, step 3, we want to establish our rejection region. So just as before, the rejection region follows from the alternative hypothesis. And so if we have a two-sided hypothesis test, then that means we have two regions for the rejection region, which is that z-stat is either less than negative z alpha over 2, or z-stat is greater than positive z alpha over 2. If the alternative hypothesis is pi less than pi naught, then the rejection region is z-stat less than negative z alpha. And then same with greater than, if pi is greater than pi naught, then the rejection region is z-stat greater than z alpha. So just as t alpha was obtained from the tables, z alpha is obtained from our tables. And then also, if we have a two-sided test, we will divide alpha in half. Otherwise, we just leave it alone. And I've been highlighting our steps blue. So step 3 is the same. Okay, step 4, our conclusion. Step 4, conclusion. You'll see it's the same thing. So if our calculated test statistic, but now it's z instead of t, is in the rejection region, then we reject h0 and accept ha. And if our calculated test statistic, again, z-stat, is not in the rejection region, then just as before, we fail to reject h0, and of course, we never accept the alternative hypothesis. And then step 5 is our conclusion. So we state the conclusion within the context of the problem, and we restate our significance level. And now, if we reject the null hypothesis, we would say there's enough evidence to conclude that the proportion is different, greater than, less than pi naught at the alpha level of significance. And if we fail to reject, then there is not enough evidence to conclude that the proportion is different, greater than, less than pi naught at the alpha level of significance. And then the p-value approach, our rule is the same. We reject h0 if p-value is less than or equal to alpha, and we fail to reject if p is greater than alpha, which is exactly the same as it used to be. And then, of course, our formulas just changed slightly, so that with the one-sided test, we now have z's, z-stat, and z-stat instead of t's. And then for the two-sided test, we multiply by 2, and we now have z's instead of t's. Other than that, it's all the same.